Okay, guys, here we go. This is the only thing that will trick you in this whole chapter. Okay, this appears on every PAT. I call it a gotcha because it's a simple rule, but kids will forget about it and then they'll get the question wrong. So this only exists with inequalities, okay? So when we're dealing with these little symbols. I'm going to show you two examples where it happens, which is these two, and two where it doesn't. So let's say we were solving this first one. We're going to just solve it like an equation. We're going to go minus 5, 3x is less than or equal to negative 10 minus 5 is negative 15. And then we divide both sides by 3. Okay, no difference there. X is less than or equal to negative 5. So there's no tricks here. Subtract 5 from both sides, divide by 3. X is less than or equal to 5. Okay. What about this one down here? Or over here? Let's do this one next. So we're going to solve by adding 7 to both sides. So we're going to have x over 5 is greater than, and negative 17 plus 7 is negative 10. And then I have to multiply both sides by 5. So I get x is greater than negative 50. And there's my answer. Okay, so up until now, these have been the ones we've been working with. I haven't shown you this thing yet. So these are all normal, no issues. Now, you'll notice in these different versions, everything's the same here, except for I've thrown a negative 3 on the front here. Up here, it was a positive 3. And over here, this is a positive 5. But down here, it's a negative 5. So let me show you what happens. We're going to solve it the same way. Minus 5, okay? So we're going to have negative 3x is less than or equal to negative 15. So this is very similar to what I've done here, okay? Now, here's the trick. To solve from here, I need to divide both sides by negative 3. As soon as you divide or multiply, in this case division, by a negative number, something happens. Okay, so here, solving this, I had to divide both sides by negative 3. I divided by a negative. As soon as you do that, this inequality sign flips and goes the other way. So the answer here is x, okay, and over on this side I've got positive 5, because negative 15 divided by negative 3 is positive 5. But this sign is going to go the other way, like this. Okay? And the reason that happens is when you're dealing with negative numbers, what it does is it flips the relationship from, in this case, less than or equal to greater than or equal to. Up here, we kept everything positive the whole time, and there wasn't any, multiplication or division by a negative number, so the inequality sign stayed the same. But as soon as you divide or multiply by a negative number, this sign flips. Okay? And if you don't do that, you'll get the question wrong. And every year on the PAT, they'll have a question like this, and then they'll have the answer with the correct number, but with the sign unflipped. Like they'll have this as an answer to this inequality, and you'll go, oh yeah, no problem. But this one will also be there, and most of the time kids pick this one and of course get the question wrong. So anytime you multiply or divide by a negative, the sign flips. So looking over here quickly, I'm going to add 7 to both sides. No problems there. I'm going to have x over negative 5 is greater than negative 10. But now to solve this, I'm going to multiply both sides by this -5. So I just multiplied both sides by a negative number. So as soon as you times, or in this case divide by a negative, this sign is going to flip. And everything else stays the same. So x, and over on the right hand side I'm going to have positive 50, because negative 10 times negative 5 is positive 50. But now this sign is going to go the other way, like that, okay? Because I multiplied by a negative, okay? So I call it a gotcha because it's a simple rule, but it's quite often overlooked, and if you do that, you'll get the question wrong, and we don't want that to happen. Okay, guys.